Hello, now I know I'm between you and lunch, so let's keep it crisp and first find out how this works. I guess I could advance. I thought so, but I cannot. How do I get to the next slide? Janis, help. How do I get to the next slide? It should.
The arrows. Right for next.
Okay, the other one. I hold it up right down. Okay, so this is about the coverage part of it, something that we encounter more and more. Ortho images, but also other kind of data, for example, processed elevation data. And the question is how to handle this plethora of different data and variable and high volume data in a canonical way. And OGC offers the coverage concept to this. And I would like to bring you the current status of it and also relate it a little bit to Inspire. So it's about the data structure and the services. It's always the two sides of the same medal that we have to take on. So in Inspire Annex II and III, obviously, we find lots of coverage types, lots of things that qualify for coverages. And this is something that therefore should be looked at in a unified manner. And that to some extent has been done by Inspire. Also looking at OGC, where we do the geo-standardization of interfaces so that services can talk to each other and can exchange data, which hopefully can be understood then. Coverages in OGC are addressed approximately since 2001. I joined the crowd in 2002, so hooray, now it's 10 years already that we are dealing with. I have background in implementing systems, handling multidimensional coverage, some 17 years. So that's what we build upon when we try to establish services that support uniformly the different application domains. Let's look at that. So there is a mighty long title for this standard. It's the OGC GML 321 Application Schema Coverages. That tells us that, okay, we base our model on GML 3.2.1, which is the most widely used version of GML, that we extend this in a way that is based on that GML and does not modify the existing part of it, it extends it in a way that we have the coverages in there. Actually, coverages are included already. If you look into the standard, I will show you in a minute what we have done there. By the way, we often try to abbreviate this long form as GML. So what is a coverage in the end? If you look into ISO 19123, we find a definition which more or less says it's a time-varying phenomenon. Actually, ISO 19123 was adopted from OGC Abstract Topic 6. It's the same text. And I would like to emphasize the word abstract here. Both specs, ISO 19123 and 86, are abstract. They define an abstract model. This does not introduce interoperability. So if you have two cars, well, they may take diesel or gas. So there's a lot of details which may make it different. And so there are many implementations of ISO 19123. You shouldn't call it an implementation, but they say it's based on it, which are not interoperable. I'll come back to that. Okay, so we need to be more concise. GML does that. It actually defines it very detailed what a coverage is, defines the data structure. And that's the document I was talking about. It defines raster structures, but more than that. We can talk about georeferenced and non-referenced data. We can talk about rectified grids, about curvilinear grids, about irregular grids, meshes, things like that. And it can handle multidimensional coverages. So it's all n dimensions, where n includes spatial and temporal dimensions. This all is being dealt with in two working groups in OGC mainly. The WCS standards working group is where the kitchen is and the standard specifications are done. And then we have the coverages domain working group where we discuss with stakeholders, exchange what they want, what we offer, and so somehow we narrow it down. So if you look into that, sorry, getting technical for a moment, into these GML definitions, we find something that is in sync, of course, with the ISO spec. We have a couple of things here. Let's focus on the green bar for a moment. Grid coverage is something non-referenced. Just a picture that sits somewhere, floats. If it's geo-referenced, but maybe not yet rectified, then it's a referenceable grid coverage. Sorry for the naming, it's not mine. And if it's an ortho image in the end, then it's a rectified grid coverage. So with these three items, we find a lot of things, and including curvilinear grids, that's something that can be done there. But it's still grids. Then we have the other family of the multi-something coverages, which is something like bundles. An image is a bundle of grid cells of pixels. So we can have such a bunch of points, then it's a point cloud, or called a multi-point coverage. We can have trajectories, then it's a curve. We can have surface, etc. That's also in ISO 19123, that's also in GML, and so that's something that is supported by the coverage standard. By the way, if you want to derive your own subtypes from that, no problem. You can specify from rectified grid coverage, for example, your specific thing, which should have only 2 dimensions lat long. That's foreseen, that's well possible. So that's what it looks like in UML. A coverage is a feature. That's what the top level says. What we have done here actually is we have added one leg. The left side, the domain set and the range set, was present, indicating the outline, the bag, and the contents of the container. What we added is the range type defining the pixel type, so to say, in a very concise way. We have taken that from SWE Commons, so the sensor web enablement has been linked in. And actually, we have added a hook for metadata in there, which is something to be discussed later on. Again, this is something very concrete, and if you adhere to that structure, then the coverages are interoperable, can be interchanged, and the systems can understand it. So this is a concise definition as opposed to ISO 19123. With Inspire, they have taken a slight deviation here and saying, okay, time we want to treat specifically, and actually they have resorted to WaterML because WaterML supports time series. This is not a coverage. It's a separate construct there. The issue actually is, well, put a buoy somewhere into the river and measure values. It can measure single values. But image time series, for example, cannot be dealt with right now. So we have structures like the one you see above. That's the WaterML representation for the time series. And currently one discussion is to extend WaterML to have a little bit more. And that leads to that model here. I would like to contrast that to the coverage model and its simplicity. So I find this is a little bit difficult to follow. Actually, there is something else which I get to the next one, because also something else has been introduced by Inspire called an interleaved representation. They say, well, an image time series or any measurement actually is done over time. So actually, when we receive the first one, we don't yet know the second one. So we cannot put everything into one bag. We need to have slices, time slices. Makes a lot of sense. But this is a logical property, is a matter of encoding. It's a matter of data organization. And so actually in a coverage view, we say, well, it's a way to represent the coverage internally, but the contents as such, the information content, is not different. What Inspire has chosen is we have we have two different hierarchies here. So you have to pick whether you want to use this one or that one, and then you are tied into that, and each one has slightly different properties. I also would like to point out that this is just time series now. What if it's not a time series, but for example an elevation series? You obtain values, let us say, into the earth, into the water at different height levels, one after the other. It doesn't always have to be time which you want to interleave. So I find this a very special solution and a little bit down to earth, let's say. Let's come back to the coverages. So how can we link in metadata? This is the one thing we have added, and just for the XML geeks among us, this is the way how you can link in any kind of metadata, what you want. You can associate it with a coverage. The web coverage service will not know about that, but it will deliver it. So whatever you put in there, in addition, it will come along. So you don't have to specialize your WCS for delivering the special metadata as well. It's just that the WCS does not allow search for this. This is catalog functionality. Now, back to the encoding. Actually, we have several cases how we have to encode that. GML is what we have by definition. But hey, you don't want to encode an image in GML. So we want to have something that's called a special format, like TIFF, for example, identified by the MIME type, and then you get a TIFF image. So this is the GML part of it, where you get all the components like the domain set, range type, range set, and maybe your metadata. You may want to have, wait, let's first go for this one, the blue one. NetCDF is a way to encode all that information, and NetCDF is pretty powerful. It can contain all the complete information. TIFF cannot, so you will lose information. But so what? You requested it. If you want to have the best of both worlds, use the multi-part mixed, which is defined by MIME, by IETF, and then actually have an X-link mechanism here. In there, you don't have the data themselves, but a link to a file containing the pixel payload. Inspire also uses X-link, but they are working on a different approach right now. We'll have to see what that will look like. But with that, let's go to the service part. The web coverage service actually on principle is something very simple. I want access to my spatial data, and because they are so big, I often want partial access to it. Actually, that can mean two things. The one thing is trimming, what we call it. I want to have a cutout, let us say a two-dimensional cutout from a two-dimensional picture, or a three-dimensional cutout from a 3D picture. But you also can do a slicing. I want to have from an image time series one particular time slice. I want to drill down to get one particular temperature curve over time for this location here in Istanbul. Then you would get a one-dimensional coverage. So you can reduce dimensionality during cutout. And that's pretty much all that the core does for us. Everything else we have pushed into extensions, and implementations can choose to support it or not. So there is band extraction, or as we call it, range subsetting, scaling, reprojection, interpolation, the data encodings, etc. And then application profiles finally allow us to bundle that for particular domains. I will show that in a slide. First, a little bit about one thing which maybe is not that obvious. There was something in the last slide saying query language. Yes, we have established a raster query language. Just as you search your relational database, you can do this now on coverages. And you can do something like time series, thresholding, find interesting things, NDVI computation, histograms, aggregation, or just do a web map service. This is a particular query type for us. So this is the web coverage processing service. One example for an application profile which bundles such functionality is the Earth observation, WCS. This is confined to latitude, longitude, plus time, nothing more. No four-dimensional, no one-dimensional things. We have added EO metadata to it. We can do hierarchical groupings of coverages, and these can be combined into mosaics, and we allow retrieval, which includes that you get back the metadata records, as I described earlier, for those images that are part of your result, that are participating. This recently has led to Met Office saying, hey, that's cool, let's do the same thing for the Med-Ocean community. So that has started, and I'm curious to follow the progress. We will do that in OGC over the next months and maybe the next year. Now this is the big picture. Yes, we have a master plan, and that's it. You find the WCS core here, and you find the extensions that are lined up here. And so we are working our way currently in OGC to complete that and to have all the specifications available and in place so that they can be implemented. In parallel, we do an implementation so that we know it works once the standard gets adopted. And at the bottom, you find the application profiles. Okay, now coverages are also being dealt with in other contexts with sensors. And so I'm often asked, how does that relate to the sensor web enablement? They also deal with coverages. Actually, in O&M, there is a point where coverages are linked in, and this is where our worlds meet. SWE Common and other friends allow you to do very, very detailed and very different data structures. You can describe virtually anything with that. It's very powerful, and that allows them to capture any sensor that's out there and describe it, and then it can be homogenized and put into a service. And this is where we come in then. We let them do this bulk work of integrating and fusing, and then we can offer that via the uniform model of coverages. So upstream integration for SWE, downstream delivery and services, that's the web coverage service. Okay, Outlook. We are currently doing a project called Earth Server. It's an FP7 infrastructure project where we specifically set up on-demand processing for Earth sciences with an emphasis on scalability. So 6 times 100 terabyte databases is what we are establishing. The technical platform is the rasterman system, which is an array database system or analytics server, as people would say today. We strictly rely on the web map service, web coverage service, and WCPS query language, and we add in for the metadata search XQuery then, and then we do 3D presentation of all of that in X3D. So that should give nice images at some time. For now, you see the 6 use cases, the 6 use cases here: cryospheric, snow and ice; airborne, that's NASA; atmospheric, geology; ocean; and just for the fun of it, no, there's some reason behind, Mars. Because we want to see how far we can stretch our coordinate system standards in OGC. So finally, with the coverages, we have a toolkit that works in n dimensions, supports many different coverage types. Implementation-wise, we still have to explore all the possibility. Yes, it's based on ISO 19123, but that's not the point. We are interoperable because we base it on GML. This is independent from the service model, and therefore an SOS, for example, a sensor observation service, can deliver a coverage, which then can be served by a WCS. So coverages can float between the different standards and can be exchanged. We have an extensible WCS suite where you can pick how much you want to have from it, simple download or up to the flexible query processing. And at that time, having looked into that, I really need to say the Inspire people have done a tremendous lot of work. So bringing all that into the Annex themes is a lot of work and a lot of detailed issues. We know about some of them ourselves, so really congratulations to that hard work. At some places I have chosen to go own ways, not exactly sure why. But anyway, it's great work. If you want to know more about the coverage services, there is an information page which is listed down there. And with that, let me stop here and thank you for your attention.
Thank you very much, Peter. Do we have any questions? Yeah? Stephen, can you please pass the microphone here?
I have 2 questions. I am not familiar with GML service, GML coverages. So I would like to know how data are coded in this
organized
coverage.
And encoded.
Not coordinates, but data itself. It's binaries, or it's in text format, and other. If you have some practical experiments or practical usage of this.
Yes. So no, my slides are gone. There was this picture before showing the different encodings, and I know this name is misleading. It's called GML. Application schema for coverages. That does not mean, by no means do you have to encode your data in GML. You can do that if you want, but you use GML only as a logical description to say concisely what it contains. You can just as well deliver a coverage in GeoTIFF or in NetCDF or any other format that is out there. So there is no limitation to textual format. We just offer this as one of n encoding formats. Second question about practical use. We have implementations of the WCS. I'm aware of the academic sector, of 3 of them, but I have heard signals that that industrial implementers are going for that as well. It's always when you get some question and then they vanish again, don't telling you anything about what they do. So this is definitely coming. and I have lots of requests. How should we do this and that? How can we do conformance testing? And the biggest example that we want to do ourselves is the Earth server, where we have over 0.5 petabyte of data in the end for distributed query processing. Oh, earthlook.org. There is a demo site out there where you can try it out. earthlook.org.
Do we have any more questions for Peter? No, it seems no. Just a comment from my side. I mean, I suppose for the slight deviations that you mentioned that in certain thematic areas in Inspire they have taken for the data specifications, I can only invite you to speak if you have not done already so with my colleagues and other members, because I'm sure there will be some explanations, for example, for different directions. And of course, I mean, we have to consider also the use cases that are considered and everything. So probably sometimes we are not driven just by the standards when they exist, but also what actually on the use of what exactly we need to attain. And probably standards not always cover this.
Yeah, I've participated. Actually, I've been invited to 3 meetings where we have discussed the coverage concept, and I've presented this and also on other occasions. I mean, we know each other. And my point is just that I find that some decisions here restrict too much and might lead to issues in the future. But we will see.
Exactly. Experience will show, I suppose. It's back to the lessons learned that you mentioned before. So whether they are constrained or not, or they play their purpose, and then we may have to revisit things and improve if necessary.
Right.
I suppose the same is true from the standard side.
As always, I'm very open that we discuss this, that Inspire and OGC liaise closer with respect to coverages, so I'm very open to do that.
Okay, thank you very much again to all the speakers and of course the audience. So time for lunch, I suppose. Thank you very much.